Hello, everyone, and welcome to the project explanation from business perspective. It's Monday again, and again we are here with you for the project explanation. So today's topic that we are talking about is solar panel damage classification. So this is one of the project that we are doing here at AI Spry. Why do we start this project explanation? Why do we have this project explanation? So that you get insights on what we are working on actual project and how we are doing actual project, right? So let's not waste our time and move further. So let me introduce you to Devachandan Mohanty, who is leading this project. Hi Dev, welcome to our project, welcome to the session.
Yeah, thank you, Bhupendra.
Yeah, Dev, so
So,
we all know there are 6 stages of crisp mlq, right? The first
yeah,
stage deals with business problem or business understanding, where we talk about business problem, what are the objective constraints. So why don't you walk us through business problem and what were the objective and constraint and success criteria there?
yeah, Bhupendra, let me start off with the business problem. So basically, our client, a prominent solar energy company, who are committed to clean energy. They face challenges in maintaining efficiency of its large photovoltaic PV system portfolio. Current fault detection methods are inadequate, leading to suboptimal performance and increased downtime. The company aims to maximize the uptime by implementing sophisticated detection system that leverages cutting edge deep learning techniques like computer vision. This is the business problem, and here our main objective is to maximize the solar photovoltaic system uptime while also minimizing the maintenance cost. Our business success criteria in this section is to reduce the system downtime by 15%. And our ML success criteria was to achieve an accuracy rate of at least 95% in identifying the solar panel uh, faults, basically. And economic success criteria, we want to achieve 10% reduction in the maintenance cost associated with this solar module faults. That's all.
Okay, that sounds promising, Dev. So a solar energy domain project, right? It means a lot for future. We all know solar is really, really important. So this model architecture looks really, really good, Dev. So please walk us through the project architecture, model architecture, as we call it.
Yeah. So once our business understanding and research were completed, we had to collect data, basically from unstructured data, that means videos or images. We had to collect that first. Once we had collected the data, we had to label it. So we used RoboFlow, a tool which can be used for this image or videos annotation. So we use that. In that same, we also did uh, data pre-processing, image pre-processing. After that, we had done augmentation because the data set that we had taken was very less. So it was around 800 images, which we again did augmentation and increased it to around 2000 images. Once that was done, we followed it up with a model training. Basically, we had trained it on various models like YOLO versions, different versions of YOLO. And once that was done, we evaluated it using the metric MAP. Once that was done, we had created the inference model and created an app from this, which we deployed in Streamlit. This was the
Okay, okay,
overall
yes.
architecture.
Yeah, sounds good, Dev. So we're talking about different architecture, different project, right? I mean, model series that you use. So please walk us through the actual project. What was there while you are doing annotations and all those things?
Okay, so in our research, we came up with the key defects by which this solar panels are efficiencies affected. So like we are having, you can see these were the classes which we used to annotate. So we had defective as well as non-defective. So non-defective means the clean panels. Whereas in defective panels, we had different types of defects, like there were bud drops, there were dusty solar panels, there were physically damaged solar panels, there were electrically damaged solar panels, and also some of the solar panels covered in snow. So we had taken all these cases into consideration while collecting the data. So these were
Okay,
the
great.
key defects that we considered. Yeah.
Yeah, great, 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 Dave. So next we talk about when we talked about key defects, we also talked about the models, different models you use, right? And the
Yeah.
MAP talked about. So please walk
Yes.
us through this, Dave.
So basically, we had trained it on these various versions of YOLO, and these are the three in which we got a good, you can say, uh, MAP values. So first was YOLO 5, which gave us around 0.7 in MAP 50, and 50 to 95, it gave us 0.65. So YOLO V8 performed better than this, in which we got 0.92 MAP 50 for MAP 50 and 0.85 for MAP 50 to 95. And for YOLO V9, it was a bit lesser than YOLO V8. So in YOLO V8, we got the best performance. In YOLO V9, it was MAP 50. We got around 0.88, and MAP 50 to 95, we got around 0.8. So these were the
Okay.
values. The best model was YOLO V8.
Yeah, right. MAP value of 92 is really good. 0.92 is really, really good, right? So
Yeah.
as interesting this project is, I mean, the result also looks really, really good. Right. So let's move towards the result. So when we see this, please explain the same, Dev.
Yeah. So basically here, we had annotated it to detect the bud dropping. So you can see this purple boxes are detecting the bud drops present in the solar panels. And along with that, it is also marking that solar panel as defective. Okay, so whichever solar panel has any kind of defect, like if it is a dusty, if it is having bud drop, if it is having physical damage, or if it is having, let's say, snow or electrical damage, it will mention that this is a defective panel. And in the backend, a feedback will be given to the maintenance team, and they will come and clean the basically maintenance will be done. So this was the basic idea of this
Okay,
output.
great. Yeah, great. It looks really, really good, Dev. It's really successful. We all know it's really successful, right? And it is really, really good. So thank you so much, Dev. Thank you so much for your time. And
Yeah, thank
friends,
you.
this was the project explanation. So what do we offer at 360 DTMG? Right. We who heard the project that we are doing, or that the project that we are doing, the project that we are working on. So, what do we actually offer for our students here? So, for our students, we offer challenging real-time projects that push them to their limits. They learn all phases of project methodology. You saw when we are working on project, we started with business understanding, right? That's the first part of CRISP MLQ. We talk about monitoring and maintenance too, right? Everything we will learn here at 360 DTMG. Of course, we'll learn about different tools used in industry like Python, Power BI, Cloud Platform, etc. And of course, you'll be working on research paper that are published in international journals. Yes, our research papers are published in international journals, and our students get their papers published before they have the job in their hand. Isn't it really, really exciting? It is, right? So, we have access to various free tools to enhance your learning. Free tools like Mind Map, ML Architecture Assistant, Resume Mapper, and Animated Learning. So you can visit our website 360dtmg.com and explore the learning resources page. It's just for you, completely free of cost. So you can contact us on this toll-free number. You can mail us at inquiry at 360dtmg.com, or as we mentioned, you can visit our website 360dtmg.com. We have three offline centers at Hyderabad, Bengaluru, and Chennai. Of course, there are other centers too. And also, while you're watching this video on YouTube, please subscribe to our YouTube channel. If you're watching here, just pause this video and please scan the QR code and go to our Instagram page and like the page or follow in the Instagram page. As I said, please subscribe to our YouTube channel and follow us on LinkedIn. We have accreditation to international certification bodies like Microsoft, RapidMiner, State University of New York, Future Skill Prime, Panasonic, and TCS Iron. So this is it from today. So we will be back next week with new project that we'll be doing so that you learn much more about it. Thank you so much, friends. Thank you so much for your time.